And how's everybody doing? Right. Hey, you're in analytics session ANT 211. Today we are going to talk about self-service analytics with Amazon Redshift. My name is Naresh Chenani. I'm the engineering director for Redshift, and excited to welcome co-presenting with me Kate Kim, who's a senior director at FanDuel. She's going to talk about some of the challenges that FanDuel had and how they resolved it using Redshift. Also co-presenting is Debu Panda, who is a senior manager. Today, he's going to be wearing the analyst hat and has a couple of exciting demos to show you. So here's a rough flow for today's session. We are going to talk about why self-service analytics matters. And then we're going to talk about some of the requirements around self-service analytics and what we at Redshift have been doing across multiple dimensions: compute, data, and consumption. At that point, I'm going to segue to Kate, who's going to walk you through FanDuel's journey with Redshift and the challenges that they were trying to address. And finally, we are going to go to Debu, who's going to demo the consumption layer and on how ML and analytics come together in a powerful way. Most of us have had this experience. You walk into a grocery store, you pick what you need, and you pay for what you need. And at that point, you sort of don't worry about logistics. How did this gallon of milk get here? What are the supply chain? There is a machinery in the background that worries about all those details. We want to do the exact same thing with data, where your business analysts, your data users, they focus on their outcomes, their needs, business outcomes, and they don't have to worry about infrastructure. When do I scale? When do I spin up compute? Is my access secure? Is my data encrypted? And all of that we want to sort of not have our customers worry about, and this is the kind of philosophy we have taken here. So there are different kind of personas that deal with analytics. Let's look at a few of them. So first, we have data engineers. Their job is to work on preparing, cleansing data, making it consumable. And they serve a large community of users. This include data scientists, your application developers, and your analysts, ad hoc queries. And their job is to make sure all these data is ready, available for consumption by business leaders who can then look at these insights and then predict outcomes, influence outcomes for the business. At AWS, we have seen a significant shift here. I've been in databases for over 2 decades, and when I started out, it used to be weekly ingestion into your analytics system. Then it evolved into daily. It evolved into multiple times or a few times a day, and we are now at minutes and then seconds. So near real-time analytics influences the recency of the data, and especially you see this more and more with interactive use cases, GenAI applications. So next, let's look at self-service analytics through multiple lenses. First, we will start with self-service for compute layer, then for the data layer, and finally, Debu then is going to close with self-service for the consumption layer. Let's start with compute. Our users, what they expect from the compute layer is the ability to get high performance, the ability to get started within seconds so that you can start querying the data. Gone are the days where you have to talk to a few teams to set up access to data, and it takes weeks and so on. So being able to quickly spin up some compute with high performance, being able to query that data, and not have to worry about migration. Migration is a much-headed word, right? It's cumbersome. So how can I take my, for example, Tableau application, point it to my data source in Redshift, for example, and get started? And then important for any enterprises is to stay within budget and not have cost surprises. That always makes the finance teams quite unhappy. So 18 months ago, we introduced Redshift Serverless, and it is one of our fastest growing service in Redshift. And the reason for that is it's very simple to use. It addresses each of the 4 requirements that our customers have been asking for. And again, just like my grocery store example, there is a lot of things. There is scaling that is happening automatically behind the scenes. There is compute that is provisioned. There are snapshots being taken. Data security, that is our, we consider that as a day 0, requirement 0 at AWS. Data is encrypted at rest and in motion. All of that is happening, is just happening in the background and managed by AWS. If you haven't tried serverless, highly encourage you. It's super easy to get started. Maybe a quick show of hands. How many people have tried serverless Redshift? Okay, a few of you, okay. We do have a very good way to, there is a $300 credit, so you can quickly get started and kick the tires. We'd love to hear your feedback. Next, let's talk about the self-service for data or ingestion layer. So here on the left-hand side, what you see is a bunch of data sources. And on the right-hand side, you see different consumption patterns. I'm going to spend a few minutes breaking this slide and talking about some guiding principles that we use. So one is, at AWS, our goal is, when it comes to analytics, avoid data movement as much as possible. And you will hear me talk about this. So with things like data sharing, those are the principles. Or federation, for example. There are times when you actually need to move the data, especially when data moves, say, from a transactional system like Aurora or a streaming system like Kinesis into your analytics system. Today, what I expect a lot of you would have is pipelines and teams that maintain these data movement pipelines. And now there's a problem with these pipelines. These pipelines, when they work, that's great. But unfortunately, they have a tendency to break late Friday evenings when everybody's gone. And now becomes a problem. When did it fail? Where do you resume it from? What if our customers did not have to worry about that? What if we took on that responsibility? So using that, so what we have done is we have simplified these data movement pipelines. And I'm going to introduce a few different examples. First up is autocopy from S3. This is a feature that is currently in preview. It's as simple as you point Redshift to a S3 bucket. Redshift is monitoring that bucket, and as data lands, it efficiently gets ingested. So you don't have to now maintain either stored procedures or pipelines that are copying this data every n minutes, hours, or so on. Another example is, so we talked about data recency is becoming more and more important. So with Redshift streaming ingestion, Redshift is able to directly read data from Kinesis and Kafka sources. And now think of this IoT data, log data, fraud analytics. This is where you don't want to know what happened 2 minutes ago. You want to know what happened right now. And with Redshift streaming ingestion, you're able to get very high throughput and low latency. And we have customers who are reporting latencies of under 10 seconds from a query perspective. The way this is achieved is, without Redshift streaming ingestion, what would happen is your data would be staged onto S3 from your streaming source, batched, and then the batch ingested. So we have simplified that. Then you have probably heard us talk about zero ETL. This is a theme, and where we take data from different source systems, and one example is Aurora MySQL. This is something we launched as GA, generally available 2 weeks ago, and a popular way to actually get data, transactional data into Redshift. Again, low latency, high throughput, and get rid of this data movement pipeline. You're probably starting to see a pattern here. This week, you are going to hear more announcements around theme of other zero ETL launches we are going to do. So please stay tuned for those. So now let's switch to the right-hand side, where we have the different consumption layer. So here your users, your different roles, admins, developers are accessing this data. It's super important that the data access follow rules of governance. Security has to be simple by design. So you can audit it, you can reason about it. Using things like row-level security, data masking, you're able to make sure because your users only access data that they can or they're allowed to. In the middle of this picture, what you see is a compute layer. And this is actually a multi-cluster compute. And what you're seeing here is a mix of serverless and provisioned. And there is an important thing here. There is one copy of the data. In this case, it's either in S3 as your open file format like Iceberg, or it is Redshift managed storage. These different compute layers are accessing transactionally consistent data on S3, again, a single copy. The best part is these clusters could be either in the same account or on different accounts or in different regions. Why different regions might be interesting. We have some very large enterprises where data in EU, for example, has to stay in EU. So this is where you can actually have a compute cluster in Germany and another in North America and being able to query that, again, one copy of the data. Very powerful. So we talked a lot about simplifying analytics and access to data. It's important to have a strong, solid foundation for self-service analytics. That way, you may solve the needs for today. It's important that you're able to address the needs that are like your users are going to keep growing. You will have more teams, more data. That's a consistent pattern we see. There are two popular architectures that we see with multi-cluster. One is what we call hub and spoke. There is a central ETL cluster that typically tends to be provisioned, like always on, where you're writing your streaming data or transactional data. And then you have a bunch of spokes or consumers that are accessing that data. Again, no data copies. In this picture here, you see a dashboarding cluster, science cluster. Each of those teams is paying for the compute they use. And these tend to be either serverless or provisioned. So for a workload that is, say, spiky, sporadic in nature, you just want to use serverless. So your dashboard spins up at 9 a.m., and maybe by 11 a.m., the activity starts winding down. So you don't have to pay for compute at that point. I would say about 7 out of 10 customers that I speak with use some flavor of hub and spoke. There is another architecture which is used by more advanced customers, and this is data mesh. And think of large enterprises where different teams own different parts of the data. For example, your finance team may have finance data, which they want to then share with marketing to do some analysis. Now, marketing may build some models and may want to then evaluate the financial impact, in which case they may share back those insights with the finance teams. So in this case, your data consumers can also be data producers for other teams and use cases. One great example of this data mesh architecture is the work that the FanDuel team has done. And I would like to welcome Kate to come share you more details about it.
Thank you, Naresh. Hello, everyone. My name is Kate Kim. I'm a senior director at FanDuel. I'm with the data engineering team at FanDuel. How many of you heard of FanDuel, please? Well, quite a lot of us sports fans, good. So for those of you who are not really so familiar with FanDuel, FanDuel is America's leading sportsbook, and we're the premier mobile sports betting operator. And our company's mission is to make sports even more exciting. So what does data mean for FanDuel? We're like data-driven organization, like many of your company. We process like internal, external data into a centralized data warehouse system. And every single business units leverage data, and they have a full capability of self-data analytics. And today, what I want to talk about is the risk and trading team that's in the center. The risk and trading team is the data quants. They sharpen customer betting behaviors and make predictions, and they generate a key metrics for FanDuel business, something like estimated revenue and risk profiling, and customer segmentations, and etc. And in FanDuel, we jokingly talk about we only have 2 seasons. One is NFL season, and the other one is non-NFL season preparing for football season. So in between last year's kickoff and this year's Super Bowl, like data volume and the jobs that we were executing, it grew 5 times bigger. And we started seeing some early symptoms of some negative impact because we were having just a single data warehouse architecture. So as you can see here, that the query efficiency was going below 50%. So what that means is that when a query is submitted, it is actually using 48% of its time to execute and return the result. So 52% of the time, it is doing nothing but waiting in the queue. So we started seeing this like early symptoms of negative signs. The business was growing bigger, which was good, but we could not scale up to the speed of the business growth. So going back to the risk and trading teams as our critical stakeholders as far as the self-analytics goes, so we started seeing the challenges of their, customer insights and personalization jobs. And then because of their nature of going through very granular transaction records, easily they would need billions of records to process. We started seeing that the job was taking way too long, 7 hours. That's like a quarter of a day. So 7 hours, and while that their job was running 7 hours, that means all the key metrics that we were expecting for the business was all blocked. So that translates into a $50,000 business value lost a day. And then because it was a single cluster architecture, while the resource-intensive job is running, no other queries could go through until it is done. So that means hundreds of analyst jobs that were supposed to deliver on time, it was not getting done at all. So as you can see that the customer satisfaction level was going down pretty bad. So the data engineering team, we were given with a mission to solve this problem immediately. So first and foremost, we had to recover the runtime, but we could not increase more nodes. So we had to maintain more at the same or similar TCO to solve this problem. So this is when we started looking into some of the improved Redshift features that AWS launched in the last couple years. So serverless options is one options that we started looking into. How do we solve the problem of compute intensive job to maintain, to run it at the minimal cost as possible. And then the second is that the data warehouse, we had close to 10,000 job execution a day. So the data was constantly coming in and then updating. So we had to make those fresh data available for the users to access real time. So we could not add any more ETL to copy the data over to a different clusters or different destinations, because that would mean that the data latency is going to be an issue. So the data had to be accessed real time. So we started looking into a data sharing, And then because of the uniqueness of the risk and trading teams, what they were doing, they were generating the key metrics that had to be shared across the business. So we started even looking into the further of reverse data sharing as well. And the contention issues, we had to unblock concurrent self-analytics that they were generating at the same time. So we started looking into, instead of a single cluster architecture, a multi-cluster architecture. So the solution that we came up with is that we started breaking it down, single data warehouse architecture, into a multi-cluster architecture. First of all, we separated the ETL cluster, main ETL cluster, as a producer, and then we started laying out a multiple consumer clusters using data sharing capabilities. So as you can see that we added like analytics consumer cluster, and then we gave a very specific risk and trading consumer cluster, and then some other multi-cluster architecture. And for some consumer clusters, we converted them to a serverless. For example, risk and trading, because we knew that they were reading billions of records, and it's a very resource intensive job. But then you would probably need 2-3 hours a day for the compute processing. So we added a serverless as an option so that we can maintain the minimal cost as much as possible. And then we also added reverse data sharing so that the risk and trading consumer cluster can be a producer at the same time, that the data can be shared back across the multiple consumer clusters as well. So the result that we have seen is pretty good. We were able to recover the job runtime within the SLA. It was actually a 3 times better SLA with their jobs. And then we were able to increase our query efficiency to 73% from 48%. And we were able to reduce actually the cost per their jobs using serverless 10 times lower than what it was. So that all entails to a 15 million revenue upside per year. I wish it was a month, but we're not there yet. So it's a 15 million revenue upside a year that we got the success out of it. And then the satisfaction, of course, is trending very, very nicely too. So this was a combination of a data engineering, collaborating with the business stakeholders at the same time. So I just want to highlight that this wasn't just a one team effort. It was a multi-teams effort to put this through. So what are we thinking as a next step? The next step is that, a lot of these jobs are created by data scientists and data quants, and we have definitely a room to revisit maybe using, ML technology to be adopted. So what we're doing is that we're evaluating AWS and Redshift ML options for specific insights that they are generating, something like personalized betting options and real-time risk profiling, and then see if that is more fitted for ML approach. And as much as we were able to drive self-analytics service in the BI area, we're hoping that we can drive further self-servicing in ML AI spaces as well. So that kind of wraps up my presentation. And I want to bring Debu onto the stage, and then Debu's going to talk about what kind of AWS ML investment they're making. Thank you.
Thanks, Kate. Football, and Redshift serverless, Redshift data sharing. What an interesting story. I love it. So customers like Kate and many of you guys tell us, like, you guys want to democratize the access to your data and analytics to your end users. And based on all the discussions that we have, what customers want to use is that they want to provide a very nice SQL editor to their users, who can easily build, SQL queries for ad hoc analytics and do visualization, for quick insight. And the other thing that we hear about is that many customers have started to use machine learning. How many of you guys are using machine learning? Yeah, there are many. So what we did with Redshift is that we added a feature called Redshift ML about a couple of years back that allow users, SQL users, like data analysts, database developer, to build machine learning model for a variety of use cases, whether it is product recommendation, customer churn prediction, revenue forecasting, just by using SQL. And you don't have to know Python or R or any machine learning tools. You just have to be a SQL expert. You can just run your create model command by using SQL, provide the training data by providing a SQL or a table a name. Then you can tell Redshift ML which column you want to predict. That means the target column. And what Redshift does is that it works with SageMaker Autopilot, automatically trains your model, compiles it with SageMaker Neo, and then deploys into Redshift, whether it's a provisioned cluster or serverless, as a user-defined function. Then you can do your predictions by using SQL. So machine learning, we brought machine learning to SQL and your database. So there are several customers like JobCase. JobCase is a job site that does more than 1 billion predictions per day with Redshift ML. And we have 80 billion predictions are being done collectively by Redshift ML customers every week. And JobCase, as being a job site, what they do is that they do product recommendation or the job recommendation to their users. Besides that, like Magellan Health, do a lot of machine learning capability in their available to their insurance specialist that kind of help them identify whether a customer is going to churn from a specific prescription or not, whether this prescription is going to work for this customer. So there is a lot of different use cases. Also, customers are using it for revenue prediction or customer lifetime value predictions. And how many of you guys are willing to invest in Gen AI? There are many. So we actually announced a feature yesterday with Redshift ML that allows you to build LLM, use LLM directly from your SQL. So what you can do is that, let's say you have LLM model in SageMaker Jumpstart, then now you can invoke that directly from SQL by using our bring your own model capability and allow you to do use the data in Redshift. For example, we actually published a blog yesterday that shows you how you can do sentiment analysis if you have customer comments stored in Redshift along with other data that you have in Redshift. Then, what we hear from customers is that they want a tool that they want to use for their, business analyst, and data analyst. So we have a tool called SQL, Amazon Redshift Query Editor v2, and that is integrated with single sign-on. So if your users, you want to enable to your users, they can go to directly to Query Editor using their Okta or Azure AD or even IDC credentials. We announced that feature yesterday. IDC is IAM Identity Center, and then connect to Redshift directly without having to re-authenticate again and use their credentials or their credentials to run queries. That means if someone is a member of analyst group, they can get their privileges directly on, and the analyst group is in your Azure AD, they can get their privileges directly on Redshift using the same identity center, then same identity role. And we also have ability to visualize your data, collaborate with other users. It automatically provides versioning of your SQL queries, as we hear from customers that the data analysts do not know how to use GitHub or GitLab. They want a mechanism to version control their SQL queries. It automatically does that for them. What I'll do is that next will show you a quick demo of the query editor. So as you can see here, you can have either black background or white background. So I like the black background. So let's connect to a cluster. You can just click on a cluster, because I'm using federation capability, it's automatically connected. And as you can see, all these databases you can browse. Even the AWS Glue catalog can be browsed automatically. But let me look at my schema here, the DAB, schema under the DAB database. I see all my different schemas there, including my data sharing schemas and the external schemas like the Spectrum schemas or the data lake schemas. So I can expand all my schema and look at the table views, UDF, stored procedures, and I can see the table details, like any other tool. I can just select a table, run queries directly from there. And I'm going to show you a more interesting feature is that many customers, they provide their data analysts to load data and create, their own table in their own space. So it allows you to visually create your database, tables, schemas, and also allows you to load your data. So what I'll do is that I'll create a table directly by using the auto schema inferencing capability from a CSV file. So I'll select a CSV file for my account table, and let me select that CSV file. Once the account history is selected, you'll see the actual table, the actual columns are automatically inferenced from there. So I selected the form, I selected the delimiter, all kind of for loading my data, and then I go next, and I select a new table because I want to create a new table. You can see all my columns. This actually comes from the column header in the CSV file. I can put that on a specific schema or give the name of a table. If I want to change any of the column definition, I can actually go and change the column definition. For example, I'm changing this column to varchar to let's say small int or double precision. And then I just create my table. And then if I want to load my data, I can just click load data. So it will load the data into my table. So it makes it very easy for the data analysts who are creating their own data table to load. And we provide also ability to actually load the data from S3. So as you can see here. So what I'll show you is another innovative feature that we have called SQL notebooks. So as you can see here, like I have different notebooks as well as folders. You can create your own folder, like Google folder that you have. You can organize your notebooks. So the notebooks capability is for you guys, like for SQL users. It's not Python notebook. It is actually for any SQL users. We have only two things. One is that annotations. That means you can provide different kind of headers by using different kind of markdown language. And the other one is SQL. So like, for example, I have given this header as sales report, and then I see here, like, for example, different cell here. One cell that I ran earlier, you can see the data there in a visual format. So I have another cell there. I can run all the cell, but I can run only a specific cell also. So I run that cell. So if you see here, after I run the cell, I see the data there. You can download the data in CSV or export data in CSV format, or what I want to do is a quick visualization. So I click on the chart there. So you see there, then it provides an ability to change the different kind of graphical format. So I want to change that, like these are the different charting mechanism we have, different formats you have. I just selected bar chart. I can select my the value and the column name, and I can hear it. I can give the header, the column header, x-axis header, y-axis header, all those capabilities. And you can share the notebook. As you can see here, this notebook is already shared, but you can share this notebook to your team members. So this is how easy for your analyst to run queries and use it for their day-to-day analysis. So with that, what I'm going to do, go to the next demo. You can see here, like Naresh, give a quick intro of the streaming ingestion. That streaming ingestions allows you to bring data from different streaming engines like Kafka or Kinesis, and then what in this demo what we are doing is that we are bringing the credit card transactions. We are bringing the credit card transactions, all the like in the point of sale, something is happening, that it is going to Redshift through Amazon Kinesis as a stream. And then we have Redshift ML, which I have created a machine learning model to see the data and make a predictions whether that the credit card transaction is a fraudulent transaction or not. Okay, and you can visualize this data either using Query Editor, or you can get the data using an EJDBC ODBC tool. And also we have an API called Data API. We have more than 11,000 customers who are using Data API and running more than 25 million queries every day for different kind of event-driven applications to ad hoc analysis application. So, but what I'm going to do is the quick demo of this, this specific use case that we have. So let's get started. So let me first go to the Kinesis console and then create, because I have already created the a stream, data stream called customer payment transaction stream. So let me expand this and see whether the data is actually coming into this stream or not. So if you see here, there are get records, and there are a lot of data is already coming into the stream. That means basically the stream is ready to be consumed by Redshift. You must be wondering, where do I get the point of sales data directly? So what, I do not have point of sale data. So what I have here is a Lambda job, populating the data. So let me just quickly show you that, Lambda job. So if you see here, the Lambda job, so I want to run some test and then, bring the data. So actually, deliberately I selected the wrong one just to show that, it was a real demo, not a cooked up demo. So I'll select the right stream and then start the stream now, start loading data. So the test data, now the Lambda job is started, start run the data. So I'm back into the query editor. So now I have two different, SQL notebooks. So I'm going to go to the first notebook that actually allows me to ingest the data from the Kinesis stream. So what I'm doing first is that creating an external schema that is, reading the Kinesis stream. Okay, if you see here, is basically the create external schema from Kinesis, and I'm using the default IAM role. So this is already created, so I am not going to run that, but I'm going to run the next cell just to show that the stream is being read. So that's, you see this, basically the stream, the credit card transaction stream is being read as a part of that external schema. So then what I'll do is that in order to read the data and materialize into Redshift, I have to create a materialized view, on the top of that stream. So if you see here, I'm creating a materialized view. So if you see here, I'm just reading the data from this stream, and then I am, that materialized view is created. And then, what I want to see is that I want to see whether the data is coming in or not, just by looking at the materialized view. So I'm going to run the, query against that. So actually, I didn't select this SQL properly. So then, see this, the actual data is actually coming in. You can see this data from Redshift. All my credit card transactions are in here. So what I'm going to do now is that, create a machine learning model. And then you'll see how easy it is to create a machine learning model. So I'm going to transition to my next notebook. So now, as you see, this transactions are there. Now this is in this notebook. You can see the create model command. So it is nothing but the from and if you see a select, that means that's the training data that I'm providing to this model. And as you see here, I do not have anything like about the problem type, whether it's a classification or anything. It automatically does that for me. I just specified what column I'm trying to predict. So if you see here, the target is the transaction fraud, whether the transaction is a fraud or not. And then I'm going to provide a name for the function, the prediction function. So that's the function name called FN customer CC FD. And then I am using a S3 bucket where the training data is prepared, because Redshift ML automatically parses the data, pre-processes data, makes it available to SageMaker for the training. And this training takes maybe like from 90 minutes to 3 hours, depending upon the size of the data. It's trained. But if you see here, I use the show model command to show the status of the model. As you can see, the model is ready, and it was trained. You can see the query that I used for the test data or the training data. If you see the model type, it uses the XGBoost, but I had not specified anywhere, the model type is, and then you'll see the auto. If you are an expert, SageMaker expert, and you want to know more about the, in the SageMaker console, the SageMaker autopilot job name is there also to do there. So now what I will do is that the model is ready. I want to check whether how accurate is the model as of today. So I'm running this, the SQL, to check the accuracy of the model. And I can see here that my accuracy of the model is 0.92. That means it's pretty good. So let's now try to use this model to see whether it can predict my transaction or fraud or not. So I came back here. So what I'm going to do here is that I'm creating actually a view, and in that view I'm using the prediction function. So if you see here, you'll get this PowerPoint, and the demo is embedded there. So you can see there's a prediction function there that I'm using, the same prediction function there, and the actual data from another, from that materialized view, and creating this view to use this data. So if you see here, that's the function that I'm using, the FN customer CC FD function. So, and I'm passing all this data from my materialized view directly to that data into the table, and then I am going to create this view. So then, this view is actually I also have created already. So I'm going to do is run a query against that specific view to see whether the data are fraudulent or not. So as you see here, I'm going to run my query, and as you can see, there are a lot of transactions which is arriving are actually are fraudulent transactions, because again we are kind of cooked up here. In a real life environment, probably only few there will be fraudulent transaction, but just to so this use case, we created a lot of fraud there. But this was a demo that we showed. The actual real-time data is coming in to a Kinesis stream. We are using Redshift ML to do a real-time predictions. This is how powerful AWS Analytics and Redshift has enabled you to do. So with that, so you can try Redshift serverless today. We provide you like $300 credit to try Redshift, and Redshift ML is available to every user who is not every user, but if your organization has blocked you to use it, then you can't use it. But every customer can use Redshift ML wherever SageMaker and Redshift are available. And there are a lot of resources that we have. We have our books. Even I authored this book. I'm putting a plug there, Redshift ML book that we published recently. With that, what we in this presentation, what we did, showed you how AWS enables you to do self-service and near real-time analytics by bringing your data, real-time data, whether it is from your streaming source, whether it is from S3, or it is from your operational database, and then Redshift provides different tool to consume that data. And Kate showed you, how FanDuel transformed their data warehouse with a multi-cluster architecture. Thanks, everyone. And please complete the session survey.